Okay, so 111.3, the exercises. This is really an extension of 110, where they give you like a practical use of their method. All right. So I'm not going to go through the computation. When I first read it, it kind of reminded me of the what would have done in the past when you were using tables. This goes back a long time ago. You would interpolate. All right. So that was called linear interpolation, which is basically fitting a line. But here they carefully select um, this log thing. All right, this is a carefully selected problem. They give you the estimates to it, and they're saying the log. I'll highlight this for you. Make sure you know what we're talking about here. That they give you this. They give you this. They give you this, and they give you this. Now, when I said they give it's approximately those values. It's not an exact value. It's approximate, and they're pretty good approximations, by the way. All right, and what they want you to do is they want you to find a log of 28.7. All right. Now, granted, you might say, how does this relate to the prior thing? Well, it's really the same thing you're going to put down. You're going to list the set A down. Now, what's a set A? It's those log numbers. All right. Now, I hope you realize that if you're doing this over here, let's forget about what they've given you. If you're given this sequence of numbers over here, you now know that A1 is equal to 1.4150. And then what do? We do the difference. Now, granted, it's almost ridiculous nowadays to do this because we have a calculator. We could easily do log base 10 of 28.7. That's not a problem. All right? Now, what I'm going to do is what we did in the past, right? And, you might say, oh, you're cheating because you're using a calculator. I did use calculator to do this, by the way, and I compute the differences. And I did that. I did 1.4314 minus 1.4150. I wrote that difference down, yada yada yada, just like we did in section 110. And then I got the D1, and then I got the differences too. And again, these were carefully selected. I got these numbers, all right, and they were all the same. So now my D2 is minus 0.0006. All right. Any D after that is going to be 0. All right. Then what I do, I write the formula down for AN. Right. Now here comes the problem. You have to start asking, what are they asking for? And what they're asking for is, you have to realize that what this A1 is, it's really the log. Let me write this over here. It's really the log, right, of what number? 26. All right? So that's what A1 is. Right, so then the question is, how could you do the log of 28? And this is A1, I'll say. I know they're approximate. I'm just saying we want to do log 28.7. All right. So now you got to start thinking about, what would this term be? A what? All right. So kind of looking at it, it's not going to be an integer number, right? Like A2 would be 20. Let me write that down. So if I were to write this down, A2 would be 27. Again, this is A1. A2 would be 27. A3 would be 28, right? So what's that going to be? It's going to be 3.7. Right, so we're actually looking for A 3.7, which might seem strange to you. All right? Again, this is A3, and this over here is A4. We're actually looking for A 3.7. Right, so we use the formula, all right? And it's remarkable. It really is remarkable. Let's take a look at this. So A at 3.7, it's going to be A1. We've done this before. But now the n is not integer, it's a decimal number, 3.7. 3.7 minus 1 times the D1. Again, we just computed that before. And then it's going to be 3.7 minus 1, 3.7 minus 2 over 2 factorial times the D2. All right? And now the D3 is 0. I don't know why I wrote it down, by the way, but it's 0, all right? So really what am I computing over here? All I'm doing is computing this. And I'm going to say that's equal to that over there. It's remarkably good, though, right? The approximate's remarkably good. So the claim over here is, you know, I certainly did use a digital computer, which I think in Wells's time that would have considered a miracle. It's still a miracle. There's no doubt about it. Digital computer's still a miracle. But I did this on a calculator. I got this over here. And using this method, yeah, I cheated using a calculator too, but using his method, right? So I'm not like I'm taking the log of 28.7 on my calculator. I'm actually using the method. I'm doing a computation, right? I get 1.45790. It's remarkably close, really is. All right. Now, you may not see the obvious application of this, but back then, I guess it was a better approximation, right? It's not a bad approximation for what the log of 28.7 is. Now, granted, they had pretty precise tables back then. Some of the books, the log books they had, were just enormously big, and they could do really good approximations with their logs. But anyway, here's the deal. The method that we're using is the method we learned in 110, but now we're getting not like integer numbers for the subscript. We're getting these decimal numbers. And that's going to be like a challenge for you to figure out what the decimal number is that they want to go to, all right? Now, granted, if you need to reach out to me, my name is Ron Bannon. My email address, again, is Bannon, that's B as in boy, the @ symbol, NNON.US. Thank you.